Hey guys, this question is called as minimum travel time and it was a medium level question for the div 3. So what you can see is that this question is actually based on a college student who wants to visit his classes and is bored of going to the hostel and his classes each day. So what we are asked to find is that we are asked to select some classes so that he can minimize the distance he travels. So this is an interesting problem. You can read this problem here. So just to give a summary of what this problem means, we are given four integers, that is 2, 3, 2, 2. What this means? The first integer means that 2 means that there are two buildings other than his hostel. These two buildings are the classes that he has to attend. So there are two classes that he have to attend, 1 and 2, and then there is a building denoted by 0. And then what this 3 means? That 3 is the number of edges actually. So there are three edges, one edge between 0 and 1, one edge between 1 and 2, one edge between 0 and 2. This edges means that it's a road connecting these two buildings actually, and it is actually a graph problem, and these edges are bidirectional. It is known as bidirectional, that is he can travel from 0 to 1 and 1 to 0 all the way, like that. So what you have to find, we are given 2. This 2 means is that we are given some classes actually. He has to attend some classes and we are given a choice of these classes, like the order which he had to attend these classes, and then we are given a value k. So what this k means is that we have to select that many classes minimum, at least he has to study that many classes to clear his course or to clear his semester. So our task is to select such classes such that he has to travel minimum distance. And the problem with him is that after he attend one class and then the class is over, he should return to the hostel. So let's take this case, and we are about to assume that each of these buildings actually connected by a 1 unit distance. So let us take this case and we can see that if we have to attend the first class, he will go to the first class. It will take a one distance, and he had to return from the first class to the 0th class, to the to the hostel. Then we will go to the second class, which is again one distance apart. Then he had to return to the hostel. As you can see that this total operation will cost four distance. That is exactly the first test case, which is actually giving 4. So what does this mean is that we can actually see that we only have to go consider this, find this one-way distance, because since this is always returning to this hostel, we can say that we can multiply it by 2 and actually find the answer. So in order to solve this problem, we have to do some simple BFS search. So a simple BFS search means is that we can find the distance from the hostel to each of these nodes. So as you can see that first I will take all the children of the hostel, that is the 0th node. I will take all children. Children are 1 and 2. So once I take the children, I will update a value called as distance, and I will update it to update it by 1. I will increase it by 1. Distance I will increase it by 1 after while I move to each children, and the distance of the hostel node will be 0 because there is no distance between hostel and hostel actually. So I mean that we can actually find the distance of 1. So what I'm actually trying to do is that I will actually find the minimum distance of each of these nodes from the hostel. So I will have a distance array. I will have an array called as distance. So what this distance will contain is that distance will contain all the distance of the node. Like for the one node 1 will have as a 1 distance from the node 0. Node 2 has a distance of 1 unit from the 0. And then what I will do is that I will actually take this array, like the array which I have to array which he has, the class which he has to attend. I will actually take that array, like the array is now 1 2. I will take that array and append the distances of that append the distance of that class to another array. I will append the distances of that class, I will append the distance of that class, and then what I will do is that I will do a simple sort so that I will get the first minimum k elements, and then I will do a linear scan through this array and then find the minimum distance for the first minimum distance. I will do a linear scan for the first two arrays. I will find the minimum distance for the for attending the first k classes, and then at last I will multiply by 2, because as I said earlier, he is going to the classes and then returning to the hostel again, to the classes and return to the hostel. So it's a two-way trip. So in each, after finding the distance, we have to multiply by 2. So if you don't understand what I meant by this, it's actually fine, because this is more of an implementation type problem. So the logic is not much of an importance here, but I will show you the method what it means. So coming on to the code, actually coming on to the code. So coming on to the code, actually you can see that I have read all these values, nmsk, and I have created a vector called two-dimensional vector of graph. This is how we actually take graphs, guys. This since this is by that, so I have had two integers x and y. This the u and v, you can also say u and v. So in each of the m edges, I am reading those edges, and into that location I am pushing back the y. That is in the for the xth node I will push the y value, and for the yth node I will push the x value. Why I am doing this is that is bidirectional, so we can go move from x to y and also from y to x. So I am also reading the array, that is the array. This array A is the number of classes, the classes which he has to attend in the order. So we are having a distance array, and I am getting the minimum distances from the hostel to each of the nodes. So this function will return me the nodes the distance array having the nodes distances of each of the nodes from the hostel. So what does this function get minimum distance to? Is that this is basically a BFS search. So I will say what BFS means. BFS means breadth first search. So it means that we are visiting each level once and then moving to the next level. So it's actually for a graph. Actually, we are first visiting all the children of the first node, and then only we will move to the next node. That's what we mean, and we will not visit the nodes which are already visited. So in order to take track of the nodes which are visited, I will say that it's bool visited of n plus 1 equal to 0. Else I am initializing this visited array, and then I am initializing this distance array to 0. I added a queue here. So what this queue does is that, so whenever we encounter a child, like for example, for a BFS, when we encounter a child, we will add this child to the queue. So what this means that why we are adding this to the queue is because we have to first we have to process this child and then this child, and we have to process them in order. Like we can't, after adding to this one, we can't process this child directly, because first we have to process this child completely, because it's actually a breadth first search. So first we have to take priority children. So queue is very efficient here, because it actually FIFO, it follows a rule called FIFO, which is called as first come first out mechanism. Like if I'm adding this one first, this child first, it will actually be the first one to get out of the queue. So since I am adding the child of this node first, so this will be first processed, then only this guy will be processed, and then only this guy will be processed. That is, these nodes will be processed in a specific order, which is helpful by using a queue. So here I added queue and used a queue, and then I pushed the node u to q. That's u is actually the hostel number, that is 0. I pushed 0 to q. So till the queue is empty, that is till I have done operation all the elements of the queue, that is I am pushing each of the child to the queue, and when I have finished the operations, when I finish operating on all the childs of the queue, then only I will actually empty the end the queue. That's why I am saying that while not queue dot empty. So I will take the front element of the queue, that is I will pop out the front element, and then what I will do is that I will check all the children of that node, all the children of that pop node. So as you can see that in the first case I have pushed the first element, that is 0. I have pushed the 0. So I will push the 0, and then I am popping the 0, and I will check all the children or if it is another children, I will take all the children, and if these children are not visited, I will add them to the queue and will continue the process. As you can see, if this is not visited, I will actually if it is not visited, I will actually add them to the queue, and then I will mark that those nodes are actually visited. If it's already visited, I will just continue the function, because there might be cases where this will lead this will enter some other node might lead to this node, but this node is already visited, so we don't have to process this node again because it's already processed. So we'll do like that. So what this function does, the distance of graph of x comma I equal to distance of x plus I. So what this node means, that we can say is that x is first actually the hostel. This x is first actually the hostel, and this hostel is assigned a distance of 0. So when we are moving to the children of this hostel, the hostel, that is the other classes children. So as you can see is that these nodes which are connected to the hostel will have a distance of 1 plus the distance of the hostel. Distance of the hostel is 0, so the distance will be 1 plus the distance of the hostel. So that is why I are actually incrementing the 1 plus the distance of x. So consider this one, consider this node. So this node will be processed when we are actually processing this node, and when we are actually processing this node, what you can find is that this node will be added. This node is not visited, so it will be added to the queue, and its distance will be this distance will be 1 plus the distance of this node. Distance of this node we already know is 1, so it's actually 1 plus 1 is actually 2. So this is actually 2, right? You see, distance of this node is actually 2 from the hostel. So this distance of this node from the hostel is actually 1, and then this child is actually 1 unit away from this one, so it means that its distance is actually 1 plus 1 2. So this is actually the way of finding the distance of each node by using this function. Like, we are actually updating the distance starting from the hostel node, because we are doing a BFS, and we are actually visiting the order nodes in a sequential manner. Like, we are actually, this distance of this is actually 1 plus the distance of this, and distance of this is actually 1 plus the distance of this, therefore the total distance is actually 2. So that's it. So I will update the distance array like this and find the distance of each node from the hostel, and then I will return the distance. So once I return the distance, I will get the distance array here, and I will declare another array called as allowed distance. What the allowed distance does is that it will actually push those distances which are allowed. There are some classes which are not allowed. Like, you can see that in this question, you can see that there are some classes which are not allowed. So as you can see, there are some classes which are not allowed. Like here 1 2 3 4 5, 4 is not allowed. 1 2 3 5 6 4, there is no class like 4, but actually we are given we might take 4 as the node. So what you can find is that we are only taking those allowed classes, and we are only taking the distance of those allowed classes and then updating into a something called as allowed distance. So what we do is that we will take the, in order to take the first smallest k distances, we simply sort this allowed distance array. So by sorting this allowed distance array, what happens is that we will get the first k elements, first smallest k elements in the beginning. So we will just add the first k smallest elements, and then we will multiply by 2 and print. Why are multiplying by 2 is because this is a two-way trip, actually you have to multiply the distance by 2. So this was all this question. It was a fairly medium, you can't say medium because it's actually easy question. Only thing there was a little bit difficult was the BFS. If you didn't know BFS, then it would be a little bit tricky for you. So that was this question. So I hope all of you understood this question. Thank you guys, thank you for listening.